To measure the distance through a mountain for a proposed tunnel, a point C is chosen that can be reached from each end of the tunnel. If the length of AC is 3,800 meters, BC 2,900 meters, and angle C 110 degrees, find the length of the tunnel. So yeah, you could measure this distance, and then get this angle with like an angle measurement device, and you can estimate the straight line distance from one side of the mountain to the other. So like I mentioned in another video, that they've got these roller length measures. You can, like, you walk on the ground and it rolls and it tells you the total length that you've walked. But you can imagine it's not, you can't just walk along the side of the mountain right here. It's obstructed. Like, this is just a simplified drawing. You go from one side of the mountain, and then you're going to have to take a pretty shallow angle here to make a straight line distance. You got to go way out. This is probably not to scale at all, right? And you got to do the same thing over here. You got to go way out, so you can have a straight line. It's not going to be that large of an angle. This is like not drum scale, I would say. Then you could use an angle measurement, one of those surveyor devices, to get an angle between the two ends of the mountain. So you get this angle, and now you've got two side lengths and an angle of a triangle. I'm not a surveyor, but I'm just trying to give you a sense. I'm trying to make this feel more real to you. But even in engineering, there's applications where you would need to solve triangles. Geometry is everywhere. So, okay, we want to solve this triangle here. We've got two side lengths and an angle. So, but that could mean side angle or side angle side. Side angle would use the ambiguous case of the law of sines. Well, no, this is side angle side. So that's law of cosines. So, okay, we're trying to solve for this distance x. So, okay, law of cosines is there's three separate equations. Each is centered around a single angle. So we're going to be centered around this angle. So we start with the side length opposite of the angle we're working with squared. So x squared is equal to the sum of the squares of the adjacent sides minus 2 times the product of the adjacent sides, times cosine of that main angle. Okay. So we've got, let's see, cosine of 110 times 2,900 times 3,800 times 2. Okay, 3,800 squared plus 2,900 squared, then minus this. Okay, now take the square root of that. And so 5,513 meters. Okay, and there you go. That's it. Now, if we wanted to, we could continue to solve for these other angles, but we don't need to for this application. But we know that if you want to continue to solve the triangle with the law of cosines problem, you apply the law of sines, but you have to, there's ways you have to be aware of a few things when you do that. So if you go watch the video where we go through the law of cosines section in the textbook, or where we work the more general example problems from the section, not on specific applications, just we're just given a side, an angle, and a side, or three sides, and we want to solve the whole triangle. Make sure you check that out so you understand exactly how, if you need to solve the entire triangle starting from a law of cosines scenario, that make sure you understand how to do that.